Dear parents and students, welcome back to my YouTube channel. Today I am discussing the some important 9th class science chapter number 9 middle exercise question answers, that is force and laws of motion. ಸ್ನೇಹಿತರೆ, ಇವತ್ತಿನ 9ನೇ ತರಗತಿಯ ವಿಜ್ಞಾನ ತರಗತಿಗೆ ತಮಗೆಲ್ಲ ಆತ್ಮೀಯವಾಗಿ ಸ್ವಾಗತ. ಈ ಒಂದು ತರಗತಿಯಲ್ಲಿ ಚಾಪ್ಟರ್ ನಂಬರ್ 9 ಫೋರ್ಸ್ ಆ್ಯಂಡ್ ಲಾ ಆಫ್ ಮೋಷನ್ ಈ ಘಟಕಕ್ಕೆ ಸಂಬಂಧಿಸಿದಂತೆ ಮಿಡಲ್ ಕ್ವಶನ್ ಆನ್ಸರ್ಸನ್ನು ಚರ್ಚೆ ಮಾಡೋಣ. ಸ್ನೇಹಿತರೆ, ಇದುವರೆಗೆ ತಾವು ನನ್ನ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗದಿದ್ದರೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ, ಲೈಕ್ ಮಾಡಿ, ಫ್ರೆಂಡ್ಸ್ಗೆ ಶೇರ್ ಮಾಡಿ. ನಾವು ಮಾಡಿರ್ತಕ್ಕಂಥ ಎಲ್ಲ ವಿಡಿಯೋನ ತಾವು ವೀಕ್ಷಣೆ ಮಾಡಬೇಕಾದ್ರೆ ತಪ್ಪದೆ ಪಕ್ಕದಲ್ಲಿರ್ತಕ್ಕಂಥ ಬೆಲ್ಲಕ್ಕನ್ನತ್ತೆ ನಿಮಗೆ ನೋಟಿಫೈ ಆಗೋ ಮೂಲಕ ಎಲ್ಲ ವಿಡಿಯೋಗಳು ದೊರೆತಕ್ಕಂಥದ್ದು. ಈಗ ಫೋರ್ಸ್ ಆ್ಯಂಡ್ ಲಾ ಆಫ್ ಮೋಷನ್ ಈ ಘಟಕಕ್ಕೆ ಸಂಬಂಧಿಸಿದಂತೆ ಮಿಡಲ್ ಕ್ವಶನ್ ಆನ್ಸರನ್ನು ಚರ್ಚೆ ಮಾಡೋಣ. Chapter number 9 Force and Laws of Motion in text question answers on page number 118. First question, which of the following has more inertia? First question, a rubber ball and a stone of the same size. Second, a bicycle and a train. Third question, a 5 rupees coin and a 1 rupees coin. Right answer A is inertia of object is the measures of its masses. First answer, a stone is of same size as that of the rubber ball will have a greater mass because the stone will have more inertia. Second answer, a train has much greater mass than that of a bicycle, so the train will have more inertia. Third one, 5 rupee coin has more mass than 1 rupee coin, so 5 rupees coin will have greater inertia. Main question number 2, in the following example try to identify the number of times the velocity of the ball changes. A football player kicks a football to another player of his team who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks it towards a player of his own team. Also identify the agent supplying the force in each case. Right answer, given below are the number of times at which the velocity of ball changes. Whenever a force will be applied on the ball, then the velocity of the ball will change. A answer, when first player kicks the ball towards another player of his team, then the velocity of ball will change because first player applies some force on the ball. Second answer, when another player kicks the ball towards the goal, then the velocity of ball will changes. Here again the force is applied on the ball. Third answer, when goalkeeper of the opposite team collects the ball, then the velocity of ball will change. It's become 0. Here the goalkeeper applies some force on the ball to stop. Fourth one, when the goalkeeper kicks the ball towards his own team, the velocity of ball changes because goalkeeper applies some force on the ball. Question number 3, explain why some of the leaves may get detached from a tree if we vigorously shake its branch. Right answer, we know that the leaves are attached to the tree and are in a state of rest initially, but when the tree is vigorously shaken, the branches of the tree comes in the state of motion, but leaves tend to maintain their state of rest. As a result, the leaves gets detached from the tree and fall down. Question number 4. Why do you fall in the forward direction when a moving bus brakes to a stop and fall backwards when it accelerates from rest? Right answer. Initially, when the bus is at rest, our body also follows the same state. But all of the sudden, when the bus starts to move, the lower parts of our body tends to move with the motion of the bus. But the upper parts rejects this state of motion and continues to be in a state of rest. This results in a sudden jerk backwards when a bus moves. Also, a person standing in a bus will be in a state of motion. And when the brakes are applied to lower part of our body comes to the state of rest, but our upper part is in a state of motion. Hence, we tend to fall forward when the bus applies brakes. On page number 126 in text question answers. First question: if action is always equal to the reaction, explain how a horse can pull a cart. Right answer. In order to pull the cart, horse pushes the ground with its foot in the backward direction by pressing the ground. As a reaction of this force, the ground pushes the horse in forward directions. As a result, the cart is pulled by the horse in the forward direction. Question number 2. Explain why is it difficult for a fireman to hold a hose which ejects large amount of water at a high velocity. Right answers. From Newton's third law, we know that every action has an equal and opposite reaction. So, when a fireman holds a hose pipes which is ejecting a large amount of water at a high velocity experiences a backward push due to force of water flowing in the forward direction, hence making it clear that due to the action of force in the forward direction, the force is applied on the pipe in backward direction, thus making the fireman difficult to hold the hose pipe. Question number 3. From a rifle of mass 4 kg, a bullet of mass 50 kg is fired with an initial velocity of 35 meter per second. Calculate the initial velocity of a rifle. Mass of gun M is equal to 4 kg. Mass of bullet small m is equal to 50 gram. 50 gram is converted into SI units kg. 50 into 10 to minus 3 kg. Initial velocity of bullet is v is equal to 35 meter per second. Let's recall velocity of gun b is equal to v meter per second. Before firing the bullet, both gun and bullet were is rest, so total movement is 0 after firing. Movement of bullet is equal to m small m into v. Movement of gun is equal to capital M into v. Total movement of bullet and gun after firing is equal to small m e plus capital M e. Since there is no external force applied in the system, so total movement after firing is equal to total movement before firing. mv is equal to capital M is equal to 0. Capital M is equal to small m v. V is equal to small v is equal to minus m v divided by capital M. Fill the all values 50 into 10 to minus 3 into 35 divided by 4. Simplification ಮಾಡಿದಾಗ minus 0.44 meter per second. Here negative sign shows that the recoil velocity of the gun is in the direction of opposite to the velocity of the bullet. Question number 4. Two objects of masses 100 gram and 200 grams are moving along the same line in direction with velocities of 2 meter per second and 1 meter per second respectively. The collide, and after the collision the first object moves at a velocity of 1.67 meter per second. Determine the velocity of the second object. Before collision, m1 is equal to 100 gram. 100 gram is converted into kg. 100 divided by 1000, 0.1 kg. m2 is equal to 200 gram. 200 divided by 1000 is converted into kg, 0.2 kg. v1 is equal to 2 meter per second. vt is equal to 1 meter per second. After collision, m1, m2, v1 given 1.67 meter per second v1. Since 1 kg is equal to 1000 gram, that's velocity of second object after collision is v2 meter per second, since there is no external force on the system. Dear friends, if you have any doubts in this chapter middle exercise question answer, please share and subscribe my channel. Thank you.